In this lesson video, we are looking at Mathematics 1510, which is pre-calculus A. We are going to focus on November, October 2015 question 3. Let us start. This is the actual question paper. I don't know if it's visible enough, but we can see that question 3. We have two graphs, which the first one it's F. You can see is the absolute value graph, and then the second one is G, which is the parabolic graph. Now today we are going to focus on this question paper. It will be a bit longer. I'm talking about the lesson video, but then I'll try to be as quick as possible, and at the same time I'll try to make sure that I cover all the concepts which are very important when answering this question paper. Now what is important is that in most cases the graphs, they'll be given in terms of a diagram like this, and then the scenario will be given above or below the graphs. So what I advise you is to always read the scenario before answering the questions, and then at least fill in the information on top of the graph, because it's much simpler when you're looking at the graph with all the information available on the graph, instead of looking at the graphs and go back to the scenario and look at the graphs again. Now what I'm going to do, I'm going to interpret the scenario and fill in the information on top of the two graphs. Now the question is saying, the scenario is saying the sketch shows the graphs of function f and g defined as, this is the first equation we are given. We can see that this equation is for the absolute value, and then for g of x it's this one. Now looking at f of x, you can see that we are not given any value, but g of x we are given q as 3 and then r as 25.2. And then in this case we know that the values that we see here, the value of q and r, it's the actual turning point for the parabola. So you can go to our graphs, and then basically we already have the coordinates of the turning point. The coordinates of t, which is -3, maps 25/2. Now we all know that the value of q, when it comes to the actual graph, it won't be positive, it will be negative. If you want to know the actual value of the translation of the graph, you can simply take what is inside the bracket and equate to 0. X plus 3 is equals to 0, then x is actually -3. So the graph will be shifted 3 units to the left, not +3. From the graph it will be positive, but from the actual translation it will be negative. Okay, and then from there, respectively, both the graphs of f and g pass through a point A, which is this point. What can you say about point A? You can see that point A is on top of the x-axis. You must know that always, actually any point which is on top of the x-axis, y is 0. So we can actually say x maps 0. Same goes to B, its x maps 0. And then what else can we say about point A? We can see that this point is on the negative side of x-axis, and then B is on the positive side of x-axis. Let us continue. Okay, through point A on the x-axis and the point C on the y-axis. Now let us look at C. This is our point C. As you can see, C is on top of our y-axis. So any point on top of y-axis, the value of x is 0. And then we know that The y coordinate will be positive because it's on the positive side of the y-axis. Now when you continue, A is the salient point of the graph of f. The graph of G also passes through the point we are given this. -6 maps 8. Now this -6 maps 8, it's any point on top of G. So it must be on the negative side since it's -6, and then on the positive side of y-axis. Negative side of x-axis, positive side of y-axis. So it might be somewhere here, but it must be below the turning point, because 25/2 is greater than 8. So you can say we have -6 maps 8. B on the x-axis and T, which is the vertex turning point of the graph G. O is the origin. So this is the origin. We already talked about the turning point T. I hope you can see this. Okay, now let us go to the questions. Question 3.1, determine the equation of G and write it in the form of y is equals to g of x, it's equals to ax squared plus bx plus c. So I tried to redraw the two graphs. Now the question is requiring us, actually the question requires us to write the equation of G and then we write it in the other form. Now in this case you can see that the problem, we don't have the value of A, but how do we calculate the value of A? We need any point which is on top of the graph that we are focusing on, which is graph G. In this case we have this point, so it is possible for us to calculate the value of A. So the coordinate is -6 maps 8. Now we all know that the order pair is arranged in this manner. It's x maps y. So from the equation where we see x, we substitute by -6. Where we see y, we substitute by 8. And then we all know that f of x or g of x is the same as y, which is our output. So g of x we replace, actually substitute by 8. And then we have a -6 plus 3 squared plus 25/2. And then from there we can simply solve for a. So we have a -6 plus 3, it's -3. -3 multiplied by, actually -3 squared, it's 9. So inside the bracket we have 9 multiplied by a. Then we have 8 minus 25 divided by 2. And then we have 9. A, it's equals to 16 divided by 2 is the same as 8. I'm trying to express this in terms of common denominator, and then we only have 16 minus 25, it's actually 9, -9. And then we divide both sides by 9. A, it's equals to -9/2. This is the same as multiply by 1/9. Then we have a, it's equals to -9 multiplied by 1, it's -9, divided by 2 multiplied by, we can write it like this. Then this, the numerator level, we are left with 1/2. And then we conclude, actually we go back to our equation where we see a, we substitute by this, x plus 3 squared plus 25/2. Now remember the question, it says we must write it in that form. So I have x plus 3. When I expand this, plus 3 plus 25 divided by 2. G of x, it's equals to negative 1 over 2. X multiplied by x, it's x squared. X multiplied, actually 1 multiplied by 3, it's 3. 3 multiplied by 2, it's 6. So you have 6x plus 9 plus 25 over 2. From there, negative 1 over 2x squared, negative 3x, and then we have negative 9 over 2 plus 25 over 2. This is equals to 1 over 2x squared minus 3x plus 25 minus 9 over 2 over 2x squared, negative 3x, plus we have 16 over 2. And then we can conclude that our equation is plus 8. We are done with 3.1. Let us move to 3.2. Question 3.2, it's saying write down the coordinates of t and then determine the coordinates of the points A, B, and C. We can go to our graph. Now what we need to calculate exactly is this, this, and this, because we already know this. We already know the coordinates of t. Now we need to calculate the coordinates of A, the coordinates of B, and C. Let us start with C. For C, now what you need to know is that suppose you have any point, and then that point somehow, point P, that point somehow you have the value, actually you have one of the coordinates, you are looking for the other one. In order to find the other coordinate, you need the equation of that graph, which this point is on top of, and this one. Where you see x, you substitute by this. Or let's say you have something like this, you are looking for x, you have y. You need the equation which this point is on top of and that given coordinate. Then you can calculate for the other coordinate. So the same goes to C. We can see that C, we have the y coordinate, and then we are looking for, actually we have the x coordinate, we are looking for the y coordinate. So from the given, actually from the equation of the graph that we have, we cannot use f because we don't have the equation of f for now, but we can use g because this point is also on top of graph G. So from the equation of graph G, we can substitute x by 0 and calculate the value of y. So for point C, we have 0 maps y. Then we need the equation which is g of x is equals to 1 over 2x squared minus 3x plus 8. So where we see x, you can substitute by 0. 0 squared minus 3, 0 plus 8. So this will be 0, this will be 0, and then we're left with 8. Now we conclude that C is 0 maps 8. For point A, we have the y coordinate, we are looking for the x coordinate. Same procedure as how we determine the y-coordinate of C. We need the equation and the other coordinate. So in this case, y is 0. We all know that g of x is 0. So where we see y, we substitute by 0, and then we have this equation. From here, we are going to solve for x. So let me just rewrite this like this. So the first thing that we need to do, we need to simplify the bracket. We need to get rid of the bracket. And then we also need to get rid of this negative sign. So we multiply each and every term by the number causing the fraction and negative. So we multiply by -2. We also multiply this term by -2, this one by -2, also this one by -2. So from here, 0 multiplied by -2 is 0. It's equals to this. We'll get rid of this, and then we are left with this. And then -3 multiplied by -2 is positive 6x. Positive 8 multiplied by -2 is -16. And then from here, basically we are solving for x. We factorize. We are looking for two terms. You multiply them, they give you -16. You plus minus them, they give you positive 6. And then those factors, it's 8 and 2. And then from here, x is equals to -8, or x is equals to positive 2. So as you can see, we have two solutions. We have two values of x. Remember, we have point B and point A. Point B, it's on the positive side. Point A, it's on the negative side. So from here, we can conclude that A is -8, maps 0. And then B, it's actually 2, maps 0. There is another method on how to solve for x. Let us quickly go through it. The second method, we are going to use the other form of the equation. It's actually x maps 0. So we substitute by 0, -1/2 x plus 3 squared plus 25/2. So we multiply by the term causing the fraction. We have -2, -2. So this will get rid of this, and then we are left with x plus 3 squared, and then this will get rid of this, and then we are left with -25. From there, we transpose -25 this side, we are left with this. It's equals to positive 25. And then we square both sides. Remember, on the right hand side, you always put plus minus. Then the square root will actually get rid of this. Then we have x plus 3, it's equals to, now square root of 25, it's plus minus 5. So we can actually write this in two ways. It's positive 5, or x plus 3, it's equals to -5. Then from here, it's x, it's equals to 5 minus 3, or x, it's equals to -5 minus 3. And then we have x, it's equals to 2, or x, it's equals to -8. And then we say this is b, 2 maps 0. And then a, it's -8 maps 0. So you will check which method you prefer. And then we can conclude by writing all the points. So we have A. Let me actually use a different color. We have A, which is -8 maps 0. We have B, which is 2 maps 0. We have C, which is 0 maps 8. And then we have T, which is -3 maps 25/2. We are done with 3.2. Back to the question paper. Question 3. Determine the equation of f. So we are actually going to the absolute value, the absolute graph. So going to our graph, there is a lesson video whereby we look at how to analyze an absolute value graph. Now looking at this graph, you can see that this graph was shifted to the left. So it simply means that the value of q, this q, will be positive from the graph, but the translation will be negative. So we actually need the salient of the graph, which we already have it is point A. And then remember, we just calculated point A. Point A is -8 maps 0. So we already know the value of q from this point. And then you can see there's no up or down, there's no vertical shift. So the value of r will be 0. So basically we need 2 points. We have the first point, which is this one, the salient, the second point, which is also this one. And then remember, we have the point C, which is 8. So we can calculate the value of, actually the equation of the absolute value graph, which is graph f. So this is the absolute value graph equation, which is f. Remember, we need the salient and also the other point, which is on top of the absolute value graph. So we can go ahead and plug in our salient, x minus 8. Remember, there's no vertical shift, so it's 0. So it's f of x p x plus 8. So this is the graph. We need to calculate the value of p. In order to calculate the value of p, we need any point which is on top of the absolute value graph. So we are going to use C. The value of a, the value of y, it's 8. And then we have p, the value of x, it's 0 plus 8. This is the same as p, actually AP. We divide both sides by 8. This will result into 1. 1 multiplied by p, it's p, and then 8/8, it's 1. Then we can go ahead and conclude our equation. We have 1 x plus 8. We are done with 3.3. Question 3.4. Suppose the function d represents the vertical distance between the graphs of f and g on the interval between the x coordinate of a and o. Determine the equation of d, that is d of x. Now the question is talking about the interval between a and o. So our a is here, our o is here. Now what is happening to our graphs in this interval? You can see that in this interval g, graph g, it's on top of graph f. So the equation of d might be something like this, or like this, or like this. It doesn't matter, but what we need to take note is that we need to be careful. Take note that graph G is on top of graph F. So for us to determine that equation of d of x, we are going to take the graph which is on the upper bound minus the graph which is on the lower bound. The graph which is on top minus the graph which is at the bottom. And for the absolute value, we know that the absolute value, we have two values, the negative and the positive. In this case, we cannot take the negative one because that interval, let's go back to the question. This is the first part of the absolute value, which is the negative side. And then this one is the positive side. You can see that this interval, it's where we find the positive side of the absolute value. So we don't consider the negative side of the absolute value, we take the positive side. There is a lesson video whereby we actually explain this absolute value graphs. We go ahead and substitute minus x plus 8. It's negative x minus 8, and then from there negative 1 over 2x squared. Negative x minus x, it's negative 4x. 8 minus 8, it's actually 0. And then this is the graph. This is how we determine the graph. You simply check which one is on top of the other one, and then the top one minus the bottom one, you substitute the equations, and then you standardize, you simplify. Let us go to the next question. (3.5) Use the result in 3.4 to determine the maximum vertical distance between the graphs of f and g on the interval between the x-coordinate of A and O. Now this question, we need to understand that we are actually looking for the maximum point of this graph. We need the turning point of this graph. Remember, in this form we cannot see the turning point, and also remember that this is a parabolic graph. Since you can see the highest power is 2, so what we need to do, we need to take it from this form to this form. We are looking for this term actually. This is the maximum, this is the turning point. And since you can see that the value of A is negative, so it means our graph, it will be like this. And then we are looking for this point here, which is Q. So we need to complete the square. There is a lesson video on how to complete the square. It's not difficult. So it's 3.5 d of x. The first thing we need to do, we need to factor out this number, so it's negative 1 over 2. Then we have x squared positive 8. From there, we introduce, we have x squared plus 8. It will be 8 multiplied by 1 over 2 squared minus 8 multiplied by 1 over 2 squared. We close the bracket. Negative 1 over 2 remember the first bracket, we simply simplify inside the bracket. So 8 multiplied by 1 over 2 is 4 squared, and then this one we simply simplify it as a whole, so we have negative 16. From here we take all the terms which are raised to the power 2, we group them inside the bracket. So in this case we have x and 4, so we have x plus 4 squared minus 16. From here, we simplify the bigger bracket. This multiplied by this, and then this multiplied by this. So we have negative 1 over 2 x plus 4 squared. Negative 1 over 2 multiplied by negative 16 is positive 8. So this is the actual number that you're looking for. Then we can conclude that the maximum is 8. We are done with this question. Let us look at the following equation. 3.6. Use the graphs of f and g, not the algebraic expression for f of x and g of x, to solve the inequality. So we are given this. This is the inequality. So we are looking for the x values whereby when you multiply f of x and g of x, the value will be greater than 0. This question can be challenging sometimes to learners, but we need to focus. Let us get rid of everything here. So we are actually looking for the x values where the two graphs are on the positive side of y-axis. In order for this inequality to be valid greater than 0, we are looking for the region whereby these two graphs are on top of, actually are on the positive side of y-axis. Now look at this. When you look at this region, we can see that the absolute value is on the positive side of y-axis. Remember, from here going downwards is negative. And then when you look at g of x is not on the positive side. This is our g of x. So from negative infinity up to this point, g of x is on the negative side, f of x is on the positive side. So this is not the region that we are looking for. Now let us look at another region. Looking at b going that direction, you can see that g of x is on the negative side of the y-axis. And then our f is on the positive side of the y-axis. Still, negative value multiplied by a positive value, the answer will be negative, and then it will not be greater than 0. Remember, any number which is negative is not greater than 0. So the actual region that we are looking for in this case, look at this. Now from A to B, our f is on the positive side of y-axis. Our g is on the positive side of y-axis. Even if you continue from beyond point C, you can see that f is still on top of the y-axis, on the positive side of y-axis, and then g is still on the positive side of y-axis. So the actual region that you're looking for is this one. The two graphs are on top of the positive y-axis. So what are those x values? That is the question. X values whereby both of these graphs are on the positive side of y-axis. Now from point A to point B, both of these graphs are on top of the positive y-axis. I hope you can see this. This is the region you are looking for, this one. Beyond B, you can see that G is on the negative side. I hope you can see this. Now, how do you answer this question? From negative 8, all the values from negative 8 up to 2, this is how we answer it. From here up to here. From this point up to this point, both of these graphs are on the positive side of y-axis. That's it for this lesson video. It is very long, but I tried to cut it short to make you understand. This is Wahula SJ. Thank you very much.